بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضة لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة الديناميكا وهو الشغل المبذول أو مبادئ الشغل المبذول. طبعا احنا عارفين الشغل بيحتاج قوة وبيحتاج مسافة. احنا هنعمل شغل، أي شيء أو أي جسم هننقله من مكان إلى مكان لابد إنه يحتاج قوة ويحتاج مسافة. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in dynamic. It's called the work done. My dear student, the work done is very important lesson in our life. We use this lesson each day or each time in our life. My dear student, look at principle of work done. Look at, my dear student, the change in kinetic energy of particle when moving from an initial position to final position is equal to work done. Kinetic energy, my dear student, have mk square or have mv square. The change of kinetic energy of any particle when moving from initial position to final position is equal to work done. By the force acting on it during the displacement between these two positions, then we know that T minus TW equals T minus T naught equals the work done W. T minus T naught change of kinetic energy, W the work done. My dear student, T equals kinetic energy have mv square. Then derivative respect to time t equal d over dt have mv square. You know that m is constant. Then the dt over dt over differentiation of kinetic energy equal have m times 2v dv over dt. mv dv over dt equals mva. Why? dv over dt equals acceleration a, when derivative velocity respect to time is acceleration a, equals m dot v dot a, or product of m times v times acceleration equals mav. My dear student, what is the ma? Excellent student, is F, the force. The force, we know that the force equal product of m acceleration. This is v times f, or f times v, equals f ds over dt. We know that the velocity equals derivative of displacement. ds over dt equals velocity. Then dt equals f ds. My dear student, we know integration from t naught to t final dt equals work done. Then t minus t naught equals the work done. The change of the translate to important example. My dear student, a body of mass 400 grams is projected vertically upward. Second, this when point of projection. Look at the solution. My dear student, look at the body in the vertical direction upwards. Look at, my dear student, we change of kinetic energy equals the work done. Then, my dear student, what is the work done? Equals F times S. What is the F? Negative mg times S. Why negative? Vertically motion. Negative mg times S is change of kinetic energy. Then, by substitution, therefore, T minus half times 0.4 times 25 power 2 equals negative 0.4 times 9.8 times 15. Then find the value of tension. The T equals 125 minus 58.8 equals 66.2 joule. Another solution, we can use V square equal V naught square plus 2GS to find the value of final velocity. By substitution, about initial velocity 25 and G 9.8 and S distant equal 15. Then V square equal 331. My dear student, we know that T equal half mv square. We know the tension, kinetic energy, T equal half mv square. Then T equal half times 0.4 times 331 is 66.2. This is kinetic energy. Another example. Bullet of mass 300 gram is fired horizontally with vertically 147 meters per second on vertically bars of thickness 7 centimeters. The bullet comes out superior with velocity or initial velocity 49 meters per second. What is required, my dear student? Find the resistance force of the barrier to the motion of the bullet in kilogram weight. Solution. Look at, my dear student. Consider C is a unit vector in direction of the motion of the bullet. C is unit vector in direction at the bullet. My dear student, kinetic energy, change of kinetic energy equals the work done. T minus T naught equals W. What is the W? Equals, in this case, my dear student, we have a force as resistance. Resistance of motion equal negative R times S. This is the work done. Then T minus T naught equal negative R times S. By substitution about it, T1, T minus T naught equals negative R times 0.07. Then have mv square, V naught square 49, V final 49, V naught 147. Then half multiply 0.3 times 49 for all power 2 minus half times 0.3 times 147 for all power 2 equals negative R times 0.07. Why? My dear student, R is opposite motion direction. Then resistance equals 41,160 Newton divided by 9.8 to convert to kilogram weight. Answer is 4,200 kilogram weight. This is resistance. Look at another example. A car of mass 1.96 ton moves on horizontal road with a uniform acceleration at an instant. Then its velocity became 90 km per hour after covering distance 50 meters. If the resistance to the motion equals 400 kg weight, calculate the force of engine of this car. My dear student, what is the required force of engine of this car? Solution. My dear student, look at Suppose C is unit vector in direction of motion. C is unit vector in direction of motion. V naught equals 18 multiply 5 over 18 to convert to meter per second is 5 meter per second. When convert from centimeter per second to meter per second, multiply 5 by 5 over 18, then answer is 5 meter per second. Also, the final velocity 90 multiply 5 over 18 equals 25 meter per second. Initial velocity 5, final velocity equals 25. We know that T minus T naught equals the work done. Look at, my dear student, T minus T naught equals W. Then by using half M multiply V2 minus V naught square equals work done. What is the work done in this case? We have the force is subtract of the F minus R. F is the force and R is resistance, S is the distance. My dear student, by substitution about V1, V naught and V final and R to find the value of F. Then the equation became half multiply 1960 multiply 25 for all power 2 minus 5 square equals bracket contains F minus 400 F minus R multiply 9.8 multiply S equal 50. Then F minus 400 equal 1200. Then F, the force is 1600 kilogram weight. Another example. A hammer of mass 1.5 kilogram moves horizontally to hit a nail of mass 75 gram in a wall. We have nail. We put the nail of mass 75 gram in a wall. How to put? We use a hammer. The hammer of mass, its mass 1.5, moves horizontally to hit a nail inside the wall. Nail is its mass 75 gram in a wall. If the velocity of the hammer at the instant of hitting the nail's head equals 105 centimeter per second. What is the required? Find the common velocity of the hammer and the nail after the hitting directly. My second required, find the lost kinetic energy due to the impact, measure in joule to nearest hundredth. Number 3, how many hits are needed for the nail penetrates in the wall a distance 3.5 centimeter. If the resistance of the wall to the motion of the nail equal 157.5 Newton. Look at the solution. My dear student, we know that M1 V1 plus M2 V2 equals M1 plus M2 inside bracket times V dash. What you mean, my dear student? Sum of kinetic energy before hitting equals sum of kinetic energy after hitting of the wall. We know that we have M1 is mass of the hammer, M2 mass of the nail, V1 mass, V1 is velocity of the hammer, V2 velocity of the nail, V dash velocity of the nail with the hammer. My dear student, by substitution 75 M1 over 1000 to convert to kilogram, multiply 0 V1 equals 1.5 M2 times V2, 105 over 100 equals 75 over sum of two mass multiply V dash. By substitution, to find V dash, or by using calculator, V dash equal 1 meter per second. This is the common velocity in the wall, 1 meter per second. The common velocity of the hammer and nail after hitting equal 1 meter per second. Number 2, what is the lost kinetic energy? The lost kinetic energy, we know that equal kinetic energy before impact minus kinetic energy after impact. You know that, my dear student, the lost kinetic energy equal kinetic energy before impact minus kinetic energy after impact. Then the lost kinetic energy equal the kinetic energy before. What is the before? Is velocity 1.05 equal half multiply 1.5 times 1.05 for all power 2 minus kinetic energy after impact 1 over 2 m 1.575 times v dash 1 square. Then lost kinetic energy equals 0.039375 or divided by 10 power 5 to calculate the lost kinetic by using joule equals 0.04 joule. The change in kinetic energy equals the work done T minus T naught equals W. Then the change in kinetic energy equals the work done by the resistance. Then change of kinetic energy have M multiply bracket contains V2 minus V naught square or U square equals the work done. In this example or this case, the force equals negative R. What is R? Is resistance times S. Then half times 1.575 multiply 0 minus 1 square. Why V equals 0? Because the nail in the wall stopped in the wall. Then to reach maximum, we know the velocity equals 0 equals negative R negative 157.5 times S is the distance. By using calculator to find the value of distance is S equals 0.005 meter or 0.5 centimeter. The nail needs to penetrate a distance 3.5 centimeter in the wall. The number of hitting equals 3.5 over 0.7 equals 7 hits. The number of hits equals 7. Now we are translate to another example. A bullet is fired horizontally with velocity 540 km per hour, this initial velocity, towards a piece of wood to stay inside it at a depth 20 centimeter. If the same bullet is fired with the same velocity towards constant target of the same kind of wood of thickness 15 centimeter, what is required? Find the velocity with which the bullet will come out the target, supposing that resistance is constant. Look at the solution. My dear student, consider C is unit vector in direction of the ball. Look at, in the first case, change of kinetic energy equals the work done. T minus T naught equals W. By using substitution, then to find the relation between M and R. Negative 1 over 2M times 22,500 equal negative R or times 0.2. Then this first equation. We have two unknown, M and R. In the second case, by using same rule, T minus T naught change of the kinetic energy equals the work done. Then half M multiply bracket contains V2 or V square minus 22,500 equals negative R times 0.15. This is equation number 2. Dividing equation 2 by division 1, we substitution and the equation became 4V squared minus 9,000 equal negative 67,500. Then 4V squared equals 22,500 divided by 4. V2 equals 5,625. Square root equals 75 meter per second. This is the velocity. My dear student, now we are taking another example. Body of mass 2 kilogram moves with uniform velocity of magnitude 3 root 10 meter per second. Body of mass 2 kilogram moves with uniform velocity of magnitude 3 root 10 meter per second. A resistance, my dear student, a resistance force of magnitude 6x squared Newton, where x is displacement, which the body covers under the action of resistance meter acts on it. Find the velocity of the body and its kinetic energy when x equal 3. Solution. We know that the work done equals integration the force respect to ds. The work done, we know, my dear student, equals the product of the force and the distance. In this case, we find integration from 0 to 3 f ds. What is the f? F in this case equal negative 6x squared dx. By using integration equals negative 2x power 3 from 0 to 3. By substitution about x equal 3, then the work done equals negative 54 joule. We know that T minus T naught equals the work done. By substitution, half M multiply bracket contains V square minus V naught square equals the work done W. And by substitution, then my dear student, half times 2 times V square minus 3 root 10 for all power 2 inside bracket equals the work done equals negative 54. Then V square minus 90 equal negative 54. Then V square equal 90 minus 54 equals 36. Then the velocity equals square root 36 equals 6 meter per second. My dear student, the kinetic energy half mv square. By substitution about m2 and v6, then half times 2 times 6 power 2 equals 36 joule. This is kinetic energy equals 36 joule. My dear student, by the end of the lesson, we know the work done is very important lesson. And we know change of kinetic energy equals the work done. We use change of the work done equals change of kinetic energy. And we know that kinetic energy equal half mv square. This lesson is very important to solve many problems about it. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.